Okay, hi, my name is Andrea Smith, and like you just said, I'm from the UK, but I originally was actually born in Belgium, and my mom is Austrian, and my dad is British. So very European, and I think it's very fitting today because we're all from Europe, so it's really nice. I'm currently at UCL. I'm a second year PhD student, and my PhD is looking into the etiology of food and drink preferences. And what I mean with etiology is basically where do our food and drink preferences come from? And when I talk about preference, I mean the actual liking for food or drink, and not kind of, so the taste, how much do we like the taste of food and drink? And why am I looking at food and drink preferences? Well, a lot of the literature has shown that basically how much we like food and drink actually influences how much we eat of the food and drink. So that's why there's a kind of strong link between food and drink preferences and intake. And there might be differences in our food and drink preferences that influence how likely we are to choose more like sugary or fatty foods, and that might influence our overall risk for obesity in the long term. Generally, as we all know, most humans love sweet stuff, but they don't like bitter foods. But there's also a lot of, when you look at the population, there's a lot of variation. So some people love more, well, coffee, for example. Some people really like it, some don't. So where do these individual differences come from? And what I'm using in my PhD is basically, I'll be presenting one of my studies at the moment, where I'm using the twin method to understand how much there are genetic influences and how much there are environmental influences on our food and drink preferences. I don't know if you can still remember on Wednesday when Claire introduced the twin method. So that's basically what I'm using as well. And just a bit as a refresher, so the twin method is a natural experiment which allows us to kind of exploit and understand how much genes and how much the environment explain the variation in a trait. And the trait that I have been looking at is food preferences. And to explain the twin method briefly, because gets a bit messy, but basically we exploit the fact that there are two types of twins. There are the identical twins and the non-identical twins. And the core kind of difference between them is that identical twins share 100% of their genes versus the non-identical twins that only share 50% of their genes. But the unique thing about twins is that they were born at the same time, they grow up in the same household, so basically we can assume that they have a shared environment which is the same. So any difference, so we then look at a trait in the identical monozygotic twins and then the dizygotic twins, and so we look how much are the monozygotic twins alike, how much are the dizygotic twins alike, and by comparing the difference, we can then assume that any differences that are seen in that trait are due to genetic factors. And so that's what I did. I sent out a big food and drink preference questionnaire to twins, and I then looked at, I used a principal components analysis to structure up food preferences into 6 different food categories, and I wanted to see how much there is actually a genetic influence on how much we like the food and the different food and drinks. And then, here we go. So on the slide, excuse me, there's a lot going on there, but what I basically want to say is that I used TEDS, which is a huge population-based twin cohort in the UK, and I had a sample of around 2,800 twins that filled in this food preference questionnaire, and then I used this technique called structural equation modeling to model the heritability. So this is what the genetic influences is what we call heritability, and heritability is just simply a metric that explains how much of the proportion of the variation in the trait is explained by genetic factors at that time. So it doesn't mean that it doesn't predict anything about your risk or the trait itself, but it's only explaining how much of the variation is due to these genetic factors or the environment. And here you can see I'm comparing two twin cohorts. So I'm based at UCL in the Health Behavior Research Center, and we have got the Gemini study, which are the green bars. So you can see I've got my food preferences on the x-axis and the heritability on the y-axis. And I was comparing the heritability estimates for different food preferences between the earlier age, so the Gemini's twins were 3 to 4 years old at that time. But I don't even want to get lost in the kind of numbers here. The big message is that there are actual, substantial genetic effects that influence our food and drink preferences. And that is important because that also tells us that there are a lot of environmental influences on our food and drink preferences. And we can use that information to then target our interventions and how do we change food and drink preferences, because we all know that if we eat too much sweet or sugary or fatty foods, that we are more at risk of having a positive energy balance. And this is what I'm going to be using further on in my PhD to see how can we modify our food and drink preferences, given that there are not only genetic influences, but also environmental factors that we can possibly exploit. Sorry, that was a bit shambolic. But anyways, the big picture is that there are really strong also environmental influences that we might have to explore, and it also gives kind of strength to the idea that we need to regulate our food and drink environment, given that our food and drink preferences are shaped within the bigger picture and not just from your own predisposition. So that's basically my PhD. Well, one of my studies in my PhD, and the reason why I came here today was to kind of reconnect a bit more to the kind of molecular side of obesity research, which I haven't looked into a lot for a while, because I've now, so originally, sorry, I forgot to introduce myself as well, my background. But so I did an undergrad in biomedical sciences, and then I did a master's in public health. So it's been a while that I've looked into kind of the molecular side of things. So it was great to have like a refresher, like what's coming up and like what are like the hot areas to be looking at. And overall, it's been great talking to everybody here and also get excited about all these new ideas. Because sometimes, when you're bogged down writing, it feels a bit, depressing. But when you see that there are people out there that are doing like really exciting things, it gets you like motivated again. So that's definitely what I'm taking away from today.